For 9.3 applications, again, some of this stuff is going to look familiar because we've done these kind of problems already. But for the first one, we have E equals mc squared, and they want us to solve this for C. So I want to isolate it. First thing I want to do is divide by m. And then to get C by itself, we need to take the square root. So C is equal to the square root of E over m. For the second example, we want to solve for t. So again, I need to isolate it. So I'm going to divide by x. I have square root of t is equal to the r over x. And then to get t by itself, because it's buried inside that square root, I need to square each side. So t is going to equal r squared over x squared. Or you could leave it the way that I originally had it. We have the width of a rectangle is 3 less than the length. So if that's the width, it can also be written as L minus 3 since it's 3 less than the length. And this is the length. And then we're also given that the area is equal to 11 square feet. And they want to know what is the length and the width. So because I want everything in one variable, I'm just going to do it in terms of L. So area we know is length times width. I'm plugging in 11 for the area. Use L. And then for the width, we're going to use L minus 3. So I'll distribute that out. I get 11 equals L squared minus 3L. And whether I'm factoring or using a quadratic formula, I have to get it set equal to 0 and put it in standard form. Well, I can see that I can't factor this because 11 didn't have any factors except for 1 and 11, and that difference isn't going to be 3. So I'm going to have to use the quadratic formula. My A is 1, my B is negative 3, and my C is negative 11. So the length is going to be the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So we get 3 plus or minus the square root. Negative 3 squared is 9. Minus 4 times 1 times negative 11, we'll get a positive 44 all over 2. So inside there, I get 53 when I add those together. And if I just leave it in radical form, I'm only going to be able to take the positive case because we're not allowed to have a negative. So I can't do the plus or minus. It would just be 3 plus the square root of 53 over 2. Or I can plug that in my calculator. So 3 plus square root of 53, and then divide that by 2, and to the nearest hundredth is 5.14. And then, so that's the length, and the width would be 3 less than that, so 2.14 would be the width. If you leave it in the standard form, you would just have to subtract 3 from this radical. It's not very helpful though, right? If you're talking about lengths and widths, you really don't want to talk about radicals. Sorry about that. Didn't know there was a phone in here. Okay. We have an isosceles triangle, has legs x. So isosceles means we have 2 of the legs the same length. And it has a hypotenuse of 9. So I guess this is a right triangle as well, because we couldn't talk about hypotenuse if it wasn't right. So find the length of the legs. So because this is a right triangle, I'm going to rewrite it how we normally would think about it. The legs are x and the hypotenuse is 9. So that's a little bit clearer. And we can use the Pythagorean theorem. X squared plus x squared equals 9. And at this point I can just take the square root. So if I did that and left it in radical form, it would be 3 over the square root of 2. But remember, we could rationalize that. So 3 square roots of 2 over 2. But again, that's not really very helpful. So I'm going to do a decimal approximation. And to the nearest hundredth, I got 2.12. And then again, we're talking about hypotenuse, so I know it's a right triangle. Has a hypotenuse of 13. One leg is 2 inches longer than the shorter leg. So if one leg is x, the other one has to be x plus 2. And we want to find the lengths of the legs, so Pythagorean theorem, x squared plus x plus 2 squared is equal to 13 squared. So I FOILed out the x plus 2 squared, which is x plus 2 times x plus 2, to get x squared plus 4x plus 4. And then 13 squared is 169. So I'm going to clean that up, combine these like terms, and subtract 169. So we get 2x squared plus 4x minus 165 is equal to 0. I have no idea if that would be factorable. I'm not even going to try. I'm going to use the Pythagorean theorem. So we get negative b plus or minus the square root of b squared minus 4 times 2, which is a, times negative 165, which is c, all over 2 times a, or 2 times 2. So inside, 4 squared is 16. And then when you multiply that other stuff together and add it, you end up with 1336. Because 8 times 165 was 1320, plus the 16 is 1336. So I'm going to take the square root of 1336, because again, it's messy. And I don't want to use the negative case because I can't have a negative, so it's just negative 4 plus, and I'm rounding this to 2 decimal places. So the square root of 1336 rounded to 2 decimal places is 36.55. So subtract 4 from that and divide by 4, and I get 8.14. So 8.14 is going to be my shorter leg. And then add 2 to that. 10.14 would be the longer leg. Now, I have to be honest, I don't know what they did for the classwork problems because I haven't looked at it, but if they do want the radical, you have to leave it in there. But practically, we usually don't if you're talking about lengths of sides.